Hi there, it's Matt here, and welcome back to the podcast all about sleep loss and the modification of your genetic expression. You may not realize this, but there's a sophisticated biological system within you that operates continuously, employing 20,000 genes, your genetic workforce, each with specific functions, each following a precise 24-hour schedule where the nocturnal period manages repair and maintenance, while the diurnal period oversees energy production and alertness. For millions of years, this system functioned with remarkable precision until humans developed artificial lighting, fundamentally disrupting this ancient rhythm. When you force this biological system to operate outside its evolved parameters, widespread dysregulation occurs. Not the immediately obvious effects you already understand from feeling impaired after sleep deprivation, but rather significant disruption at a molecular level you cannot perceive, revealing the intimate connection between sleep and genetic function. Your genes begin expressing at inappropriate times. Some cellular processes that should cease continue operating, others fail to initiate entirely, and the nocturnal repair and maintenance mechanisms simply cannot function properly. The foundational study emerged more than 10 years ago through carefully controlled research examining volunteers experiencing chronic sleep restriction. In 2013, British scientists conducted a rigorous experiment recruiting volunteers to live in a laboratory environment for 2 weeks under controlled sleep conditions, limiting participants to 6 hours of sleep nightly for 1 week, then providing 10 hours of sleep opportunity the following week, before analyzing blood samples to examine genetic expression patterns within their cells. The findings were remarkable. After just 1 week of moderate sleep restriction, a pattern experienced by millions of people regularly, 711 genes showed altered expression, representing 3% of the entire human genome suddenly functioning outside normal parameters. 444 genes demonstrated significantly reduced expression, producing substantially fewer proteins than typical, while 267 genes showed increased expression, generating proteins at elevated levels. Importantly, the genes weren't changing randomly. Those that decreased activity were primarily responsible for cellular maintenance, DNA repair, and quality control mechanisms, while those that increased were stress response genes, inflammatory markers, and cellular distress signals. Even more concerning, the circadian clock that normally coordinates 1,855 genes in precise daily rhythm had deteriorated significantly, with only 1,481 genes maintaining their normal schedule. Essentially, a breakdown of the body's central timing mechanism. The research evolved 5 years later to examine tissue-specific responses and to understand why sleep deprivation promotes weight gain and muscle loss. Scientists focused on 2 key tissues, muscle and fat. Okay, admission time, I've probably eaten more protein bars in my life than I've blinked, and I'm always on the hunt for the very best. Then I found David Protein Bars. In fact, it was Dr. Peter Attia who clued me in. He was involved in their development. Knowing his standards, I trusted them immediately. Each bar delivers 28 grams of protein, just 150 calories, and 0 sugar. That's the best protein-to-calorie ratio I've seen, and the taste is legitimately good. Protein isn't just about muscle, it's essential for metabolic health and for keeping you full. And David's unique ratio makes these the most satiating bars out there. Here's the kicker. Demand has been so high that the full lineup of 8 flavors is currently sold out on the website. They'll probably be back in stock by the fall or autumn for us Brits. In the meantime, you can find them on Amazon or use the store locator on their website to grab them nearby. Try them out for yourself at davidprotein.com/mattwalker for a special deal for all you folks. Again, that's davidprotein.com/mattwalker. In 2018, researchers conducted what might seem an extreme experiment, but provided crucial insights. They kept volunteers awake all night, then obtained small tissue samples to analyze genetic activity. The results revealed contrasting responses between these tissues where muscle tissue, under sleep-deprived conditions, activated genes that promote protein breakdown and muscle catabolism, essentially beginning to consume itself for energy, while simultaneously fat tissue responded by activating genes that promote lipid storage and preparation for calorie hoarding. The inflammatory signals present in both tissues after sleep loss appeared to send opposing messages, instructing muscle to break down while encouraging fat to build up, representing the biological foundation for a troubling consequence. The less you sleep, the more your body's genetic programming works to make you simultaneously weaker and more prone to fat accumulation, regardless of your dietary choices or exercise efforts, as your genes operate against your conscious intentions, indifferent to personal goals or resolutions. The research then revealed another concerning dimension of sleep loss, respiratory dysfunction at the genetic level, where lung tissue maintains one of the body's most sophisticated circadian timing systems, with approximately 2,590 genes following precise daily rhythms under normal conditions, some increasing activity during waking hours to support active breathing, others taking over during sleep for maintenance and repair functions. This elegant system, refined through millions of years of evolution, can be disrupted remarkably quickly, as Chinese researchers demonstrated by keeping mice awake for just 10 hours beyond their normal sleep, time equivalent to a human all-nighter, and observing that more than 60% of the lung's rhythmic genes simply stopped oscillating, with only 1,030 of the 2,590 genes maintaining their schedule, while the rest lost their temporal coordination entirely. The genetic narrative then revealed how insufficient sleep affects memory formation. As the hippocampus, your brain's memory consolidation center, operates on a strict schedule where during the day it's receptive to new information. But the crucial work of transferring memories from temporary to permanent storage happens during sleep. When researchers examined hippocampal tissue in sleep-deprived mice, they found sleep deprivation had altered the expression of 1,146 genes in this crucial brain region, with most genes that decreased being responsible for communication between brain cells, the synaptic connections that allow neurons to form memories, while genes involved in cellular stress response increased, essentially creating a closed for business scenario for memory formation. A long-standing partner of today's podcast is Element, spelled L-M-N-T. Element is a sugar-free electrolyte drink mix, and for me, it was the sugar-free part that made me start using it a while back. And again, I buy my own supply just to stay objective. Beyond having the electrolytes in the right balance, the other reason I'm a fan of Element is that it's scientific. If you look up the people who created the company, you'll find some pretty heavy-hitting physiology, biochemistry, and pharmacology knowledge baked into the product. And again, all of that comes without any sugar. Now, here's the update. Element's lemonade salt flavor, which used to be seasonal, was so popular that it's now permanent. You can get it year-round. Happily, I badgered them, and they have agreed to give you fine folks a free 8-count sample pack with any purchase of Element if you use the link drinklmnt.com/Matt Walker. So for free product with your purchase, just visit drinklmnt.com/Matt Walker. And as I said, you'll get some free product. Concerning findings emerged regarding recovery sleep. When researchers allowed mice 3 hours of recovery sleep, most genes returned to normal, but a stubborn subset, particularly those involved in controlling other genes, remained altered even after recovery sleep, suggesting some molecular consequences of sleep loss may persist in the brain's memory circuits even after catching up on sleep. Just 2 years ago, researchers created a molecular map of the sleep-deprived brain using techniques that could track gene activity in different regions simultaneously, discovering that not all brain regions respond to sleep loss uniformly. The hippocampus responded to sleep deprivation by essentially reducing activity, with nearly 98% of the genes that change their expression decreasing their function. A region conserving energy and abandoning non-essential functions. While the neocortex, responsible for higher order thinking and consciousness, showed the opposite reaction, with about 96% of its changed genes increasing activity, creating a pattern where some regions reduce function while others become hyperactive but inefficient. Research this year revealed the molecular basis for why everything hurts more when sleep deprived by studying the nucleus accumbens, a brain region famous for processing pleasure and reward, but which also communicates with pain pathways throughout the body. When mice were kept awake for 3 days, their nucleus accumbens underwent transformation, where genes that normally help process pleasure and motivation were disrupted while genes involved in inflammation and stress response were activated, essentially converting the pleasure center into a pain amplifier. 2 genes stood out as particularly important: HCRT, which produces orexin to maintain wakefulness, and APO, known for its role in Alzheimer's disease, both altered in ways that could explain why sleep-deprived brains become hypersensitive to pain. As scientists examine sleep's genetic effects more deeply, they're discovering the story involves not just genes turning on or off, but sleep deprivation actually changing which version of each gene gets produced through a process called alternative splicing, where the same gene can produce different versions of its protein. A 2024 study found that sleep deprivation caused over 1,500 genes in the brain's frontal cortex to switch to producing different versions of their proteins, with many of these changes involving the molecular machinery that controls gene expression, essentially altering the expression of genes that control other genes, creating cascading changes throughout the cellular system.
So for, it must be at least a decade now, I have been an avid, probably more like rabid consumer of protein shakes. But the hard thing, honestly, in the supplement space, if you really understand and do your diligence, is this critical thing called trust. It is very hard to find a brand that you can truly trust. That's when I came across the company Puri and the really impressive founder. Even though I'm sure it makes them less profit versus other quick and loose companies, Puri takes quality more seriously than any company I've ever seen before. They have so many offerings, protein powders galore, but lots of other additions. But that's what I was focusing on here. Why did I choose them? Well, it's really for 4 specific reasons. Number 1, they are free from hormones. Number 2, they are free from GMOs. Number 3, they are free of any pesticides. And number 4, and this is the critical confidence part, every single batch is third-party tested for over 200 harmful contaminants, things like heavy metals, etc. All you have to do if you are a neurotic nerd like me, you can even scan the QRI code on the back of the product to get the third-party independent laboratory test results. That's how much trust and confidence they place in their product. By the way, if you want a recommendation, go for the dark chocolate flavored protein powder. It's just exceptional. In fact, it's wonderfully addictive. I didn't just say that. Anyway, it delivers 21 grams of protein per serving. And for folks of my podcast right now, you can save 20%. So go over to Puori.com/Matt Walker, and that is spelled PUORI.com, Matt Walker. So again, that is PUORI.com/Matt Walker, and you will get 20% off your product.
Perhaps the most sophisticated recent discovery involves separating two influences that usually work together: your circadian clock, which follows a 24-hour rhythm, regardless of whether you're awake, and your sleep pressure, which builds up the longer you stay awake. Researchers have found that in the brain, sleep pressure, how long you've been awake, has stronger effects on gene expression than the circadian clock, with brain genes responding more to whether you've been awake for 8 hours or 20 hours than to whether it's 9 p.m. or 3 a.m. But in organs like the liver, the opposite is true, where the circadian clock dominates, keeping liver genes on their 24-hour schedule regardless of sleep status. This creates the possibility that chronic sleep deprivation might cause different organs to fall out of synchronization with each other, where the brain, liver, heart, and other organs begin operating on different schedules, creating internal discord that could contribute to health problems associated with chronic sleep loss. After examining the genetic landscape of sleep deprivation, it becomes clear that sleep isn't merely rest, it's the time when your body performs essential maintenance, when genes that repair and restore get their opportunity to function, when the cellular systems that keep you alive operate their nocturnal programs. When you skip sleep, you're not just experiencing fatigue, you're forcing your genes to work with compromised coordination and unclear instructions, where some cellular processes cease functioning while others work in ways that create additional problems, and the intricate molecular coordination that evolution refined over millions of years becomes disorganized. The encouraging news is that much of this genetic disruption is reversible. Provide your body with sleep, and most genes will return to their normal patterns. But some changes persist, and chronic sleep deprivation appears to create a state of ongoing molecular disruption that could underlie the health problems associated with poor sleep. The evidence suggests that inadequate sleep programs your cells to function suboptimally, and every night, your genes await their opportunity to perform the ancient maintenance routines that keep you alive and healthy. Sleep isn't a luxury or sign of laziness. It's a biological necessity as fundamental as nutrition or hydration, because while you sleep, your genes work the night shift, maintaining the biological systems that constitute your health. And insufficient sleep causes these systems to struggle, with workers becoming disoriented, machinery malfunctioning, and the integrated system that is you beginning to falter, making quality sleep essential for optimal genetic function. And with that, I will say thanks so much for listening. No need to subscribe or like. I never think those asks really work. Instead, if you like the show, could you share it right now? Goodness, I'm feeling pushy today with a few people. That would mean the world to me. Okay, enough. Take care, sleep well, and bye for now.